All right, so I'll be presenting about Bitcoin from the inside out. Is that right? Yeah, okay. So the presentation will be mostly about Bitcoin under the cover, kind of the technology behind it, the main concepts, kind of seeing what's under the hood. It's going to be pretty fast because there's a lot to cover, so I'll be going and going and going. At the end, if you have more questions, feel free to ask them. So I'm going to start about myself. My name is Matthieu Riou. I'm the co-founder of Lifecycle. We're helping applications being built on top of Bitcoin and running all the backends, so the application developers can concentrate on their business and not running all the technology that goes behind it. Before that, I was a founder for Mamazoo, an education company, and then I worked a lot on open source, Apache Software Foundations, things like that. So we'll just get started. So from a crypto standpoint, I'll show a little bit what the crypto underneath Bitcoin is. So we'll start with crypto hashes. The hashing is a method for summarizing a message, any kind of message of any length, into just a simple sequence of number. So here you can see that message, Alice sends 0.5 Bitcoins to Bob, which is mostly what a standard Bitcoin transaction will be like, and summarize as that sequence of numbers at the bottom. Any message of any length would be summarized in the same way by using a hash function. This is SHA-1, this is SHA-256, and Bitcoin also uses RIPE-MD, but that's kind of beside the point. So the characteristic of a good hash function, as you can see, is that, as I was saying, it summarizes a whole bunch of data into a fixed length thing. It's very hard to reverse, so knowing the hash, you can never get the message back. The message just disappears. It's also very hard to find another hash for another message that would get the same hash. So you cannot sort of forge a completely different message, or in the case of Bitcoin, a completely different transaction that would give you the same hash. It's extremely difficult to do. And then a small change to the original data would create a big change in the target hash, which means that it's very easy to detect when something has been tampered because the hash is completely changed. So now for digital signature, another crypto concept that Bitcoin uses heavily. So I'll use a cheese shredder as an analogy. So say you have a very, very one-of-a-kind cheese shredder, and then you have the cheese and some shredded cheese. The point is, if someone sees the cheese and shreds of cheese that you've made with the cheese shredder, they can tell that you did it, because your cheese grater is so specific to you. You can only have grated that cheese. That's what digital signature is like. You can just tell someone, here's the cheese that I shredded with that kind of cheese. Here are some shreds that I just sent to you, and my shredder is that kind. You don't give them the shredder, of course. You just tell them what kind it is. And that uniquely identifies the cheese that was shredded. So you can tell originally, yes, you did shred that cheese. And in terms of crypto, the signature is the exact same thing. The cheese will be the original message. The shreds are the signatures. The cheese shredder, the cheese grater, is your private key. And the kind of shredder that you have is your public key. And the concepts are exactly the same. So now we're going to talk more about the blockchain, which leverages all those two types of cryptography that I talked about, and still some more. So hashing and digital signature. The hashing is used all over the place for every single blocks, every single transactions, and I'll be talking a little more about the proof of work that also relies on it. Signatures are for transactions. So the blockchain, as you can see, is just an arrangement of blocks. They are ordered. Each block points toward the last one, so you can't mix up and intercalate a block in the middle. The height is how far you are from the beginning. So right now we are about 290,000 blocks. The depth is the distance from the top. right, from the highest. That's relevant for smaller clients that sometimes don't get the whole chain together. The distance between each block in time is 20 minutes. It's kind of an arbitrary value that has been chosen by Satoshi originally. And the clients all tune themselves to make it always 20 minutes. So every certain number of blocks, it just calculates, okay, how long those blocks took. It should have taken 20 minutes. Let's make the difficulty higher or lower to get the 20 minutes limit continue. So on August 4th, we'll be at 300,000 blocks. You can just calculate it depending on the number of blocks, and that's incidentally my birthday. So we'll go into more what's a block. What's in a block? So the block is mostly to group transactions together. So you can see here you have all kind of transactions. Each of them are basically sending something to someone. It's all about referencing a past transaction to build a new one. Then the block itself has the time at which it was created, or mined, and we'll see that in a little more detail. The version, which is just for format handling, right? If the format of the block changes, the version just changed too. And then, so we'll go into the nonce and target later. The Merkle tree, you might have heard that term before. So it's one way to leverage hashes to summarize basically all the hashes of every single transaction in one single hash. And that allows the block to have a unique way to say those transactions, if you tamper with them, the original hash will not be valid anymore. So it's kind of a signature for the whole block if you want. So the nonce and the target, what are they? The nonce is just a number, a simple integer that can get incremented. It always starts at 1. When you want to build a new block, what you're going to do is hash, and that's what miners all do. You're going to start by hashing the block header. So as I said, the time, the version, the nonce, target, the Merkle tree, and the previous transaction. You build a hash with that, and the nonce equals 1. That's the kind of hash you will get at the top. It has to be lower than a given value that's set by the network. That value is called the target, and it's more or less the inverse of the difficulty that you may have heard here and there. So the difficulty will be, I don't know, it started at 1, now it's something like 300,000, actually higher. So the point is it has to be lower than that second value at the bottom that's fixed by the network. Obviously this one isn't. So what the miner will do, or anybody who wants to build a transaction, block, sorry, is increment the nonce. So now the nonce, that should be a 2, not a 1 actually. So the nonce is equal to 2. Another hash, is it smaller than that value at the bottom? Clearly not. And then you go on and go on and go on until you find a nonce that will generate a hash for that block that's low enough, so that's lower than that value. And that's why it's all computationally expensive. That's what makes block creation computationally expensive, and that's why mining exists in the first place in Bitcoin. So why all that, right? It's kind of artificial. Why finding a hash for the block and somehow incrementing a number just to be able to get the old block hash lower than another number? All seems kind of random. Well, the point is a proof of work. That's exactly what it was meant to be and designed for, is that you can prove that you have done a big amount of work to generate that hash. You tried all the previous values, right? All the nonce. You hashed that many, many times, which each time is a little bit expensive. So you have the proof that you did a lot of work. And why do you do that? Because majority rules. If somebody wants to attack the network, they will have to create all those blocks as well. So that means they have to control more than half of the network to be able to go faster than all the other half. And that's a lot of CPU power, which right now, well, so some miners, like the biggest mining guild could get there, but it's still very hard. It's people all over the place. Getting control there is very hard. So that's what basically guarantees the blocks and the fact that nobody can tamper with them. So getting back to the blockchain, We're going to go more now in the life cycle of a transaction, what a transaction is like, what it looks like. So there's one part that I won't really cover. It could be another hour talk, which is a script. So each transaction has a script in it that just kind of says what kind of transaction it is. If it needs to be signed by one person, two person, if anyone can have this Bitcoin, where the Bitcoin come from, where they go to, all of that is script driven. It's a little scripting language that's embedded. And as I was saying, it could be another 40 minutes talk. So, and ultimately, there's only a few shapes of them that exist, which are basically get money from that transaction, send it somewhere else. It needs to be signed by me. It needs to be signed by a couple more people, things like that. So the life cycle of a transaction, say you want to, well, let's say you want to transfer some Bitcoin or you want to pay someone. Basically, the transaction is going to be created for the most part by your wallet. So your wallet software will just build the transaction and sign it with your private key. So if you remember the cheese shredder analogy, it's signed by your very specific private key that you're the only one to have, and you shouldn't give to anyone, otherwise you lost all your Bitcoins. Your wallet builds a transaction with that and includes your signature in it. And then send it to the Bitcoin network, which is obviously, where it's going to get broadcasted by all the clients. So basically the transaction goes all over the place, all over the world, on all those Bitcoin clients, and everybody starts getting access to them. Then the miners will pick it up. It will pick up your transaction with all kind of others and start trying to build a block. So building the block, I just went through it, right? It's just making a hash out of the block and trying to find basically the right proof of work. When the miner picked it up and built the block, then the transaction is inserted in it, the block is already, and it gets again broadcasted to all the network. So the whole network again synchronizes, gets your block, well not your block, gets the block with your transaction in it, and everybody then tries to insert in the blockchain. Normally, if the block has been mined fine, right, it will just be inserted at the latest position in the blockchain. Everybody else will give up whatever they were doing and try to mine the next block. There can be some forks where, I think I have it here. No, I don't have it. There can be some forks where two blocks will be mined more or less at the same time, and we both try to get the head, and one of them will get orphaned depending on how fast it's been broadcasted to the network, which clients got which one first, things like that. But usually it's not really a problem. The transaction will be taken over on the next blocks, and it all goes on. Now, from an ecosystem standpoint, so there's a fair amount of software available out there. I'm sure most of you know most of them. It goes from the wallets to the mining to the different payment processors. It's a fairly complete ecosystem right now, but all of that just relies on a single full client implementation, which is Bitcoin Qt, Bitcoin E. Everybody runs that. So the implementation is good. It's a fine client to be running. It's the standard one. It does all the checks. It's been thought out pretty well. But the point is more that there's just only one. And in any kind of environment, having only one implementation has never been great. You can see with the history, with HTTP servers, with browsers, with most things on the internet. And so that's a little bit of a worry. But thankfully, more implementations are starting to appear. The overall infrastructure is kind of complex, as you've seen, right? So you have the block, the building, the miners. It involves a fair amount of crypto, and there's always some devil in the details in how things like transaction malleability, things like the actual signing, how it takes place, how the transaction that gets signed is built, and how the network itself is structured Can you have, at certain time of day, more control over the network than others? Can miners gain most of the hashing power? So that's all the kind of details that you kind of need to know, and every single application and company that would want to build something on top of Bitcoin will have to know all of that. So if you want to do that, you have to worry about things like server redundancy, protect them, handle crashes, backing up your blockchain, because it's long to synchronize, right? Data corruption, make sure you get all the transactions at the right time, prepare against possible attacks, and otherwise you end up like Mongox or one of those. So there's a lot of concepts in it. I've covered some. There's many others, right? So the malleability has been seen a lot lately and been a hot topic for discussion. There's always the double spending. That's kind of the whole proof of work, and the chain is just built to avoid double spending. It's a way to reach consensus around transactions and set of blocks. But it's always possible to do double spending if you just control who a peer is talking to. Right? If you control the view of a peer of the network, then you have a chance at attacking double spending. So it's hard to pull up, but it's always possible. Then you have always the zero confirmation risk, with a lot of merchants do, which is basically saying, okay, the transaction is valid just when it has been issued. Let's not, it can take 10, 20 minutes for a block to come up. Let's not wait. Let's just say it's fine. And then you lost pretty much every single protection that Bitcoin gives you. The anonymity is also an issue, because it's kind of a theoretical anonymity. The Bitcoin network and the Bitcoin blockchain is not anonymous, actually. Everything is tracked, and it just needs to know, I would just need to know, for example, like one transaction you did, right? Just one, your name and what the transaction you did, and then you can track that money all over the blockchain. So there's a lot of concept to understand. That's where BlockCypher is coming from. We're trying to solve that problem. We're trying to bring down the wall of difficulty to build Bitcoin applications and run all the backends, kind of abstract away all those issues around simple APIs that application developers can use, and be reliable and secure from the start, so that you don't need to worry about it. Application developer can just focus on their own business instead of focusing on all the problems that may come with Bitcoin, and just enjoy the good side of the technology instead of the biting side of the technology. So we're still working on it, but we should hopefully release pretty soon, and you can still check us out regularly. So, okay, that's where you can reach me. I think I'm kind of right on time. If you have any question.
Yep, I'll come to anybody that has questions. So just put your hand up, and I'll come over to you and give you the mic. Question, all right.
Hi, my name's David, and I'm hoping you'd talk a bit about the difference between proof of stake, proof of work,
sure,
and which one you think is superior and why.
So just so that everybody would know, I'll just zoom out. So proof of stake, okay, so proof of work, as I explained, is about bringing a lot of computing power to the table. Proof of stake is more showing that you care about that coin or that network or that basically ledger, right, that blockchain. So it gives you more right to bring a block to the blockchain by just saying, oh, I've already brought some in the past. Like, look, I've constructed all those blocks. You should trust me to make the next one. Right? I've been a good citizen so far. So there's no magic kind of system, right? they all have a problem. You have proof of network as well. You have all sort of proof of X systems that are coming up, and now have existed for a while actually. There's always trade-offs on each of them. The main thing I will say about proof of a stake versus proof of work is that, so there's 2 points that I see with proof of stake. The first one is you're trusting somebody to continue being good when they've been good in the past. And that's not necessarily something you can always assume, especially in a network that embeds a lot of value, right? So you can easily have somebody who's been good for a year, good for 2 years, mines a lot of coins, kind of contributed a lot, but then done that with a further agenda, just been patient enough to wait for that to happen and to have enough stake, and then change tactics. So that's one problem. The other problem is, again, the have versus the have-nots, is that the more you have, the more you will have. Which is not necessarily true for proof of work. Proof of work is an every day, every minute kind of thing, where it's what you have right now. Right? Maybe your ASIC miners will be worth nothing in 2 months because a new one will have come up that will have 3 times the hash power. What matters is what you have right now and what you're contributing to the network. So proof of work, well, yeah, it makes all the ASIC companies a little richer. It makes the mining more concentrated, but proof of stake would as well, because again, the more stake you have, the more you will. So I don't know, it seems to have worked well for Bitcoin. I think there's a reason why Bitcoin has gone so far. And there's some of the choices that could seem kind of, yeah, why this? Maybe why 20 minutes between each blocks, right? I would like to have faster confirmation. Everyone would like to have faster confirmation. But I don't know, it seems to have worked so far. So it's more, how many coins can we make to try every single parameter and then see which ones work better than others. Bitcoin can learn from them, right? Again, even the proof of stake versus proof of work, Bitcoin could easily start integrating a little bit of proof of stake in its proof of work. Or mixed it with other parameters. Again, the 20 minutes between each block could also be tuned. So.
Okay, other questions? Don't be shy. I'd be happy to come over to you.
Good?
Oh, we do. You got a follow-up. Okay.
Different question. So I've heard a bit about how when one mines a block, they can choose which transactions to include in the block. Can you talk a bit about that process? Is it automated? How is that choice made?
Yes, it's automated. It's actually a fairly complex process going on. So there's several levels to it. First, the Bitcoin client, Bitcoin already makes some choices as to whether it will not relay a transaction that it thinks will never be mined. So if you make a lot of transactions with not a lot of time between each of them, right? So basically you spend a lot. Well, you spend a lot. I guess you take that so transactions are chain, right? So if you take a transaction and just make a new one based on one that was just issued compared to one that was issued 3 days ago, then it will start thinking that you're submitting a lot of transactions to the network, and then it will start applying a minimum fee on your transaction. So it will say, if you fall under that rule and you have absolutely no fee in your transactions, then I will just not relay. But that comes immediately because your Bitcoin client just stops relaying it. Your transaction just doesn't go anywhere. The rationale for that is that, yeah, the miners need to still make some money. So maybe I should talk about fees a little bit, actually. The fee is what is the remaining money, the remaining amount of Bitcoin that doesn't come out of your transaction. So say you have an original transaction that's 100 Bitcoins, and you send it to 2 different wallets. One you send 90 Bitcoins and the other 9. There's 1 Bitcoin remaining. That's the fee. The miner is free to claim everything that's not claimed by your transaction. So if the difference between what's in the input of your transaction and what's in the output is the fee, the miners are free to claim it. So going back to the question, there's some already minimal fee in the clients for short-term transactions. And then the miners, as you were saying, can choose which transaction to pick or which transaction to not pick. Your standard run-of-the-mill miner will usually just pick whatever Bitcoin is saying to pick. Then when you go into mining guilds and mining pools, they're much more sophisticated, and depending on the pool, they can be even more sophisticated. And of course, they will try to get the transaction first that have the most fees, right? Where basically they can just pick the transactions that have above a certain threshold of fee, and then you will be sure that those will be included pretty fast, because every miner will try to pick it up, basically. But then there's plenty of mining power out there, and that's kind of the nice thing about it, is that no matter what, it's very, very rare for a transaction to just go completely off, right? It has to be really close to the threshold of being a very short transaction and having no fees. And even then, depending on the time, it will just find its way into a block. So the fee, I think, has more to do with how fast you want your transaction to be confirmed. So you have site like blockchain, for example, that's already telling you, and we will be doing the same thing, where you can sort of, not even sort of actually, you can tell from a transaction more or less how fast it's going to do it to the next block, going to the next blocks. And the way to do that is simply to analyze how much fees has been in the past and how fast they made it into the blockchain. But you can say, okay, about that amount of fees is pretty sure that it's going to be in the next block, just because you're among the top. So right now there's about someplace between 200 to 1,200 transactions per block. So if you're in the 200 transactions that have the most fees, everybody will want to pick you up. If you're on the lower hand, well, maybe you'll make it to the next block instead. Maybe the one after. It's going to take maybe an hour. But that's the kind of trade-off that the miners and the people building the blocks are making. And then there's all the trade-offs, right? There's all the altcoins. So now you have pools that just mine across several coins. If you have the gear to be able to mine across several of them. And then we'll just pick, depending on the time, which one they think will give you the highest return, depending on when the block has been mined. So it's, I mean, I don't know if you were at the previous session, but it's a pretty competitive industry now. And so going forward, it's only going to get more sophisticated. But the point is, there's still, as long as there's enough hash power and mining power in the network, the fees only influence how fast your transaction will get there. The transaction will always get there. And that's why mining has to stay profitable. Because if it doesn't, then it becomes a problem. Yes?
Got another question. Hang on. Here you go.
So how does that relate to scalability? Meaning when you get into a lot of, millibit transactions instead of, 1 in 10, 200 Bitcoin?
So one nice thing about the way Bitcoin has been set up is building a block. So if I don't know, let's see. So when you build a block, it only depends on the header of the block. It has no dependency on how many transactions you have. So from a miner standpoint, right, adding one more transaction doesn't take away anything from them. Right? It's not any more or any less expensive for them to add a transaction. Let me get back to that. Yeah, there. So like that last blue transaction that has nothing on it, right? Whether they add it or not doesn't really matter. What they're hashing is a header. Right? They build it once, right? They build that header, as a sequence of binary that just change the little nonce number, the little number of the increment, and then they rehash and they rehash, they rehash. If there's 1,000 transactions in there or only 10, there's very little. It only impacts the calculation of the Merkle tree, which is really fast. So there's very little impact on them. So from that standpoint, scalability is fine. We can start building 5,000 transaction blocks, 10,000 transaction blocks, 50,000 transaction blocks. The miners will not care that much. They won't really see it. Maybe a little more bandwidth. But even then, like for the most part, the miners don't even, they do, but they don't really need to run Bitcoin themselves. They can just, the whole mining API is just asking Bitcoin, okay, give me the next set of transactions, I'll just start working on them. And then getting notified when a new block is coming up so that they can just give up and get on the next one. So from that standpoint, again, mining should be fine as the number of transactions scaled up. The problem is more the network itself. Because running Bitcoin is already, I don't know if you've tried it, if you're using like maybe a simple wallet, or if you're running Bitcoin yourself, Bitcoin Qt. If you use Bitcoin Qt, Bitcoin as a wallet, well, I mean, it takes a lot of CPU, especially when it synchronizes with the blockchain. Takes a fair amount of bandwidth. I don't know if you even, like, if you run it for fun, you can look at their debug log. You'll see transactions coming by tens every second or something like that. Often duplicates, actually. So as the number of transactions start to grow and expand, you can see some sort of, you can expect some sort of contraction in the ecosystem where running Bitcoin will be harder and harder for like me to run it on my laptop or you to run it on your laptop. Right. And then it will become more couple servers, 3 servers, 5 servers, but that's fine. There's nothing that's particularly dangerous about this, as long as there's still enough actors, and there will be enough actors, right? If the number of transactions augment, then by definition, then the ecosystem is bigger, and there's just more actors, just a little bigger, that's all. So, yeah, what you can expect is more that it will become less of something that you can run at home, but more something that you will have a service running it for you. And I mean, that's what we are also doing at BlockCypher, right? We just hope to do it for, we just want to do it for the application developers and run it so that they don't have to maintain, even in their own infrastructure and in their own servers, all of that. But yeah, so scalability, there's no hard issue. I mean, no complete showstopper in sight. It's just going to be making sure it can scale, making sure there's a capacity, making sure the software is designed for that. But there's no, oh, the world going to end and Bitcoin going to fall, because there's a hard limit.
More questions? Here we go.
So the whole process of mining is basically to bring the whole network to consensus on what transactions are accepted and which ones are not. And Jed McCaleb of Ripple has come up with a different algorithm for bringing the network to a consensus, which doesn't require proof of work and supposedly you know, a lot more efficient. I just wanted to get your thoughts on what you think about that, and you know, whether you think that really works, or you know, what is there a hole in that, or you know, is that not going to scale up, or if it does prove to be, you know, a valid way of doing it, do you think the Bitcoin network might eventually also adopt that form of mining or whatever? I don't know.
So I'm not as familiar as the Ripple proof system. What I understand of it, well, as familiar as I am with the Bitcoin one, what I understand of it is that it's a blend of proof of work, a proof of network, and a little bit of proof of stake. So it's a little bit of a blend of different proof systems. again, it's hard to tell. So for proof of stake, I have my reserves, right? Which is what I was saying earlier. Proof of work seems to work. Right? Bitcoin shows that the mining community is pretty healthy. They're keeping up with all the developments. They're investing in mining more. Proof of network is very experimental right now. I'm not aware of anything that's... So it's more akin to say something, well, like sharing data, right? Having a way where you can prove that you can exchange a certain amount in some period of time. It's just like, I don't know, if you were running Dropbox at home, right? Where you can prove that you can provide that storage and exchange all that data in a given amount of time. So that's a little more experimental. It's interesting. But so for Ripple, they seem to get, the best I can tell you, right, because it's always hard to predict. So you can say, on face value, I can tell you there's nothing stupid about what they're doing, right, for sure. I can tell you that it's probably not like a home run either, where it's dramatically better than Bitcoin. They seem to be gaining some traction. That's kind of the, like from a technical standpoint, there's nothing I can tell you where I can say this is obviously better. Right? Because it's at the point where, if you look at computer science was what I was talking about at the beginning, like the crypto algorithms, that's sure. Right? Unless somebody messes with it in the sense of messes with your computer and messes with your random number generator. But if the things are the way they're supposed to be, then it's sure. There is no problem about it. Right? A hash, finding another hash is going to take you half of the, well, actually maybe 2 or 3 times the computing power that exists on Earth. And you need to get all of it to find the second hash in a time that's reasonable. That, sure. Now, proof of work versus proof of stake, it depends a lot on the ecosystem, the actors, what people are finding. Right? Like proof of stake can say, okay, it makes the rich richer, but on the other hand, you know, like the real world is a little bit like that. So maybe that may work. But it's much more a dynamic ecosystem kind of trade-off, much more than a technical one. It has technical underpinnings, but yeah.
Okay, I had one question up here I'm going to get to you next, but first, I believe you had one, sir?
So you're obviously very knowledgeable in this, and it seems to be part of your business model. But what are your thoughts on the current security issues now and long term relative to the exchanges?
So, okay, so I was trying to find a diplomatic way to say it, but I guess I won't. So there's a lot of the exchanges have been, and a lot of the services that we'll find on the Bitcoin ecosystem, right? Bitcoin was at the beginning, and still is in some part, a lot of a hobby kind of thing where you would have a lot of people who like to tinker, playing with it, and then starting putting software out there. And some services are a little bit amateurish or haven't really thought through. They also grew so fast without expecting it, right? Mongox is a typical example of that, where basically you have growth that come in your face in the amount of a huge amount of money that's coming at you every day, and they probably never stopped and paused and said, are we safe? Right? That probably never even occurred to them. Where you're on that kind of ramp up, you just kind of ride it. So in the whole ecosystem and everything, all the companies that you see are getting robbed, are just basically doing kind of obvious mistakes like Mongox, right? The transaction malleability, not being able to reconcile the transactions. All of those, in theory, should have been ironed out very well, fairly early on in the life of the company, but because the time they were at, it's not that easy or that obvious. I think that going forward, you will see some of those, hopefully less and less, because you will see more actors who have learned from the original mistakes, right? And I've said, okay, well, that's a little bit the place we're at, right? Where we're saying, okay, there's a lot of services out there that don't necessarily look very much at the performance, look very much at the scalability, look very much at the security. Maybe we can just step back a little bit, look at it, make something that we're sure is solid, and then go forward from there and take more the conservative approach. And I think you'll see more and more of that compared to before, where, I mean, and it's still kind of the wild, wild west, where somebody's just going to say, oh, I have this little service, send me money, and I'll send you more in return. So I think consolidation is going to happen. I think it's happening already, actually. The exchanges are getting more and more solid. You can see, okay, Mt. Gox went out in flame, and it used to be the bigger one, but it wasn't for a while already because they were accumulating problems. So there was obviously something wrong with it, something wrong in their operations. The other exchanges, they reacted to the transaction malleability problem pretty well, actually. Some of them had no problem at all with it. They didn't have any internal bugs. There was a little thing in Bitcoin that needed fixing, but it wasn't necessarily critical to the operation of the exchange. Some of them had to shut down just for a day, which is fair, right? When you see that there could be a major problem, you just stop for a day, see what happens. So that's fair. So yeah, again, like going forward, I think you can expect more. But that will happen less and less, basically, as more solid actors, people who are thinking about it a little more, maybe a little less like a deer in the headlight, kind of in the early Bitcoin growth that was kind of the hockey stick. Yeah, more solid actors coming up, hopefully. And from a security standpoint, right, like only the security, it's always easy. Well, easy. It's always easy to say that the system can have a hole, right? In software, there's always holes everywhere. You can find them. We're finding, like a couple days ago, a bug in the SSL implementation on Linux, the TLS implementation on Linux was found that basically made most Linux fireable for a certain type of certificate. So you could say basically fake the certificate that any Linux machine on Earth would be using and would go through. So there's always obviously that kind of bug. Bitcoin has the good thing going for it that there's a lot of money involved, and it reached a really big scale already. There's already a fair amount of market capitalization. So you can be pretty sure by now that the network itself is safe. Now, actors securing your own Bitcoin setup, well, after that, it's standard kind of, how do I secure something that's valuable and that's internet connected?
We're slightly over time. I want to get one more question in, and quick question, quick answer, hopefully.
So, recently there's been this thing of people sending out Satoshis over the network with Enjoy and Sochi, and then they didn't get mined. But recently I saw some other sort of people sending out multiple small amounts of Bitcoin. Now it's a bit more, it's 0.001. It's coming from an address 1FF, something like that. And those seem to be getting mined. Do you know what these people are trying to do and why, and what's going to happen?
No, so there's been some blocks lately that have been, like, you have very large blocks that have started forming that are like 1,200, 1,500 transactions, and then subsequently a very small one, which is kind of normal in the way the block regulation works. For the type of transaction, when you have a very small one, like there's protection for that in the standard Bitcoin implementation. There's protection for that in a lot of the Bitcoin implementation, where you just basically say, okay, if you're putting too much transaction out there, you have to put a minimal fee. And then the network can regulate that fine, right? It's just gonna be absorbed. You can't, so that's why the fee protection exists, is that you can't, even if it costs like just like say 10 micro Bitcoins, you can't overflow the network with that kind of money. You will have to send a lot of transactions to be able to overflow the network. The network will absorb it, given the money you have, unless you have a really, really deep pocket, in which case you can take maybe you can slow down the network maybe for a few hours. But that's the best you can do. Well, I mean, I don't know, people try, you know. Like, people try to find weaknesses. There's sometimes, you can check that by reading the source code and seeing what kind of protection is there. So I don't know why they didn't do that. Maybe they're just trying different patterns, adapted during the day, during the night. You see, anytime you have a server open on internet, you will see all kind of weird stuff happening to it, where people just they build little bots that explore the whole space, try things, right? So it's hard to tell why people have all kind of motivations. I think it's part of the game of having a server and running on internet. But yeah.
All right, hey, thank you very much. And if you didn't get a chance to ask your question, we've got a pretty lengthy break here right up until 11:20, when the next event will be Christoph Atlas, Panopticon, Bitcoin, Anonymity, and Freedom. So you got about at least a half an hour here, so plenty of time to maybe approach Matthieu Riou when he gets off the